Okay, so this is the start of my presentation, PowerPoint slide, and I tried not to rely on too many of these things. But what I like to do is kind of give you a condensed version of this, maybe focusing more on the design sketch or the skeleton sketch, which derives the basic size and shape of our model. But we'll talk about some other sketch elements in here too, because essentially, in the model, all three of these sketch elements in the model help define how the model comes together, and it's amazingly stable, updates fairly quickly. And by making modifications to the three sketches, the design sketch at the very top, the path segment lines that are there in the middle define the structural members that go in there, and the blocks at the end of those path segment lines, which defines kind of like the placement of holes and alignment points, as I call them. So we're going to be covering three things. Basically, I covered three things in my session. The design sketch, which drives the basic size and shape of our model, 2D and 3D sketch elements in that. Reference geometry sketch blocks, which defined where the holes and hole locations go. But ultimately, before that, it's alignment points that we can use to take all of our sketch or blocked or stacked, I should say, structural members that we put in place, and how to get those all lined up to make sure that when we change a model, everything updates with that. And then the path segment lines, which are defined by the sketch blocks in order to put in structural members, and we're going to do that referencing a power line tower. Power line tower is kind of complicated. It's got a lot of weird angles to it, hard to measure, and they've been designing these things for 80 years or more, but with SolidWorks, we're going to be able to design this much quicker, and we can put in some program bends into our model too. We don't have to rely on doing that stuff out in the field. So then my introduction here, Chris Scarlett, educator, designer, product developer, teach SolidWorks at Central Washington University. Just have a ball doing that. It's really fun. Occasional content provider for Pluralsight. My own design firm, Enterprise Design and Innovations. Yakima SolidWorks Users Group down in Yakima, Washington. About a 40-minute drive from here. And then kitty catnip. We grow weed out here in Washington State, if you can believe that. And we process catnip and package it, sell it on Amazon. So then I talk about what we're going to be covering in this session, 2D and 3D design sketches, sketch blocks. I call them reference geometry sketch blocks, to kind of give it a little bit of a name, RGSB. And it defines the end of the path segments. It provides alignment points more than anything else. And then shared hole locations are going to be on those very same alignment points. So everything coordinates perfectly together, as long as you don't get crazy with the model. And then path segments for welded structural members, those are defined by the sketch blocks, and it drives the design, and kind of gives it, and that goes beyond the basic size and shape of our model, but it defines with all the elements that are around it as we stack these together in order, and that's a good thing to remember here, is that these things are all in order. And you have to rely on that order. We're going to put our main tower leg, our support leg, and the structures in the front, structures in the back. Everything comes in order, but we need to be able to coordinate these things too. So, and then I go into a tour. Start with the power line tower, and we have an upper part of the tower and a lower part of the tower. And these are just two parts of an assembly, so it's just one assembly with two parts. I have a cycle of 4 legs that go in here. Same part, just different configurations of that part. And it all comes together in this model. So hundreds of different structural members in here as solid bodies. And we're creating this in a multi-body part environment. And it all comes together in a well-coordinated tower like this. So if you think about a tower, power line tower, top of the tower is relatively constant. From tower to tower, it's the bottom of the tower where the legs are, the bottom structure down here, that will typically vary in size. And sometimes the sizes are, quite remarkable. Like on top of a hill over here in Central Washington State, we have a lot of sagebrush and grass out here, and a lot of undulating topography. So the bottom part of the tower, like if you have a tower on top of a hill, typically the tower is very squat. But if you have that tower in the bottom of the valley, in the middle of the valley, that tower is usually fairly tall. And I think the desire here is to try to shorten the length of the cables that go between the tower. There's probably a cost savings there, and maybe have less towers to put in if you do something like that. So we're going to concentrate on the lower tower leg, and we're going to go ahead and right-click on it and open that up and take a look at that. I have other things running too. I'm actually producing a video from SolidWorks World. I want to share with my students, so things are going to be a little slow here. Hopefully not too slow. So anyways, this is the tower. If you go to the top of our feature manager tree, as you know, when you put weldments together, you get a big feature manager tree. It's really big. There's a lot of stuff in here, and inside of each one of these structural members are all the structural members that are related to it. A lot of redundancy with these solid bodies that you see in here. So we're going to go ahead and, one of the advantages of being able to do something like this is you have the capacity to be able to make all your design modifications within the graphics area over here. And just to demonstrate that, let's just go ahead and take a rollback bar, roll that back to where we only see the 3D design sketch. So a 3D design sketch, or design sketch as I call it, or a skeleton sketch as it's been called to, is based on regular 2D elements and 3D elements in here too. If you look at the top of the tree up here, you can see, you started with the top sketch on the top plane. You think about the top of the tower is going to be in a plus direction. Bottom of the tower is going to be in the minus direction, but the top planes will coordinate with each other when you put the assembly together. So the different parts that go into the assembly are going to be coordinated right in that top plane. So then I created a top plane -1 to put in our top sketch -1, and that's the one down here. And then from that I put together a 3D sketch. It puts all these elements together. Now the 3D sketch, the design sketch here, will drive basic elements of the design, the basic size and shape of it, but they're not used, for the most part, they're not even used directly. Used indirectly and sometimes peripherally in order to define our parts. But when you change this design sketch, it changes all the parts that go with that, all the different solid bodies in the part that ultimately is driven by this thing. So the thought here ultimately is that you have a sketch, typically in SolidWorks, that drives a feature. But as we're trying to do this multi-body modeling or design sketches or skeleton sketches, the desire is that maybe we could use these sketch elements in here, these sketches, whether they're 3D sketches or 2D sketches, to help define the overall size and shape of a part like this, or even an assembly with in-context relationships in here. So this is one way to demonstrate that in a multi-body part, how these design sketches can be used to define, again, the basic size and shape of our part. So let's go ahead and take that rollback bar. We're going to roll to the end, and let me show you what we can change in here. So if I take some of these elements in our design sketch and change some of these dimensions, and this is a demonstration how you go inside of this and into the graphics area and change some of these dimensions in here, it'll actually change the model. So this square up here is a little bit smaller than that square. This is 12 feet, that's 13 feet, so we're going to make that maybe 10 feet. As long as you don't make your models, your updates here crazy, the model stays together. So I'm going to change that from 12 to 10. And again, I got a video processing in the background, so it's taking a while for it to update. But as you would anticipate, it's splaying that leg out. If I do Control-Z, it brings that leg back in again. I could do the same thing down here with various other dimensions that help drive this design too. I could take the distance between these two planes in here, top plane and top plane -1. I can make that maybe 10 feet. And of course, by doing that, it's going to stretch it out a little bit. It's only going to stretch it out in this area. Bottom of the tower doesn't really change much. It does change the form of the bottom of the tower. But as I move that down, you can see it kind of changes the form, the basic size and shape of the leg. Control-Z does the same thing. It'll take that in reverse. You can see that in kind of a setback view here, what actually changes in here. There's other elements we can change in here too. We can take this gray design sketch element in here, maybe take this dimension in here, change out from maybe 6 feet to maybe 8 feet. If you do that, it's going to take that segment in here, that section in here, going to make that a little bit longer, so all these pieces are going to stretch. But think about that. As these pieces stretch in here, all the other pieces that are associated with, that are kind of connected in here, get stretched too. This diagonal, that horizontal over here, the connection plates that we have in the background, everything that's connected to that gets stretched too. And that becomes even more dramatic when we actually take some of the elements in here are associated with the structural member path segments. When we change the dimensions on those, it changes it too. So that's going to be a second way we can change our model. And of course, if you do Control-Z, you can see how that changes. Kind of takes that back to where we were before. And again, all these elements that are coordinated in here get changed too, and everything gets updated and still stays coordinated in a very stable model. Okay, so what else can we change here? We talked about some of the design sketches, or the design sketch, which defines the overall size and shape of our model. But there are other sketch elements in here too that you can see pink in the background. Didn't really explain those before. I kept my 3D sketch in the background, kind of a gray color, gray and a gray background, because we don't use it that much once we get this set up in our model. But what you also see in here are some pink elements, some pink sketches in here. These pink sketches define where the different structural member and their path segments come together. So each path segment in here comes together with like a barbell in a way, where you have a sketch block in the very end of that, on both ends of it. So this 2-inch diagonal up here, it's got a sketch block at the bottom, it's got a sketch block on top, and then it's connected by a structural member path segment. So that's your path segment, and you're going to get your structural member to go right on top of that path segment. So what do these blocks do? These blocks actually define how that path segment terminates. So if you look at the top up here, this block up here, every element in this block has got some sort of function in our model. Of course, this line defines the very end of our path segment line, which defines the very end of our structural member. This side over here defines the very edge of one of the wings of the structural member. And then this line over here, let's say, well, we got the side, the front, and this other side over here. This line down here is a center line. It's a center line based on the back of our structural member, or the back of the wing of our structural member, and it just goes right down the middle here. And what that does is provides alignment points. So you can see alignment points in here. We have two of them. One on a 1.5-inch horizontal that exists in the background. That goes in first. Remember, there's history associated with this. And we're also stacking these too. So we have to get our main tower leg in here first, 1.5-inch horizontal in second, which has got a relationship with the 3D design sketch in the background. Then this 2-inch diagonal is based not off of that 3D design sketch. In fact, if you look at the line that defines that 3D design sketch back here, that 3D sketch line back here, it actually crosses this line that represents that 2-inch diagonal. But it's actually based on it in a peripheral way, because once we get that 1.5-inch horizontal in here, we're simply going to be dropping this structural member path segment with the sketch blocks, reference geometry sketch blocks in either end of that, right on top of that alignment point. And eventually it's going to be a hole within hole location. So this is defined simply by the point up here on that 1.5-inch horizontal, and this point down here on this horizontal, 1.5-inch horizontal down here. So if we change that 1.5-inch horizontal, that 2-inch diagonal gets changed too. So we can click on this line over here. It gives us a dimension. It's kind of an arbitrary dimension of 1 inch from that horizontal 3D sketch element in the background. If we change that to something like really crazy, like maybe 6 inches, now you can see what that's going to do. So watch this corner over here. This drops down. And then that 2-inch diagonal stretches. The hole changes just slightly. That 1.5-inch horizontal stretches too, because it actually compresses a little bit, because it's actually going down. This connection plate in the back over here, that moves too. We have a diagonal off that on the front and the back of that. All those change too. And the thing about these alignment points in here that I didn't really discuss before in that sketch block, these are well-defined points in here. So this point is actually 1 inch from the very edge of here of our structural member is going to get put in place. And we could change that. We can go into that block and make changes in that block, and everything will change. But before we do that, let's just do a Control-Z and see what happens when we look at that. Let's get a good view here. I'm going to do Control-Z, and it's going to go back to its original position. And you can see all these elements are associated with that get changed too. So this gets changed in this area, but it also changes the connection blocks up here, the connection blocks down here. There's probably a dozen elements that get changed, and everything gets updated when you do that. So sketch blocks. We'll talk about sketch blocks next. Okay, so let's talk about sketch blocks a little bit. You see a sketch block in here, as I mentioned, are kind of like barbells. You have a sketch block on one end of a line, and on the other end of the line you have the other sketch block. What I did is I took these sketch blocks and made what I call a super sketch block. Might be kind of a silly name here, but what I have them, where I have them is right up here at the very top of our feature manager tree, right underneath the Weldment folder that we have up here. If we take our rollback bar and roll that back up here and take a look at the block folder up here, kind of like a folder, but it's a sketch. It just has sketch blocks in it. I'm going to go ahead and unsuppress it. The thing about sketch blocks that if you don't, if you don't use them in your model and you update your model and save it, those sketch blocks will disappear. They're not going to be there next time when you use them. So I deliberately just put them into one sketch, create them all in one sketch, and then put them all together here. Not only the sketch blocks here, but the super sketch blocks I have over here, which has that pass segment line. So let's go ahead and turn that around a little bit so we're actually looking at it front to front, and let's go into that sketch and edit it. So if we right click on it, go to Edit Sketch. Now we can see that you can see a very dramatic change in here, which really didn't happen because it's still gray. And sketch blocks are kind of like sketches within sketches. And even though we're inside of a sketch, we can make modifications to the sketch, like moving these sketch blocks around. We really don't see anything as being blue. So we can go inside these sketch blocks itself, like maybe this 3-inch sketch block, and see what makes up there, what makes up that sketch block. So as I mentioned before, we have our pass segment line, which is going to come down on this side, and then that's going to define where the spine of that structural member is going to be. It's going to be right where the two wings of that structural member come together, the backbone of it, you might say. You have one wing coming out this way, and then you have the other wing going perpendicular to the screen, away from the view here. So that's going to be the backbone of our structural member. This is going to define the very front of that because the structural member pass segment is going to end right at that point. So it's going to define the front. It's going to define the left-hand side of it. And then this line back here, we're going to be using that for alignment. So every structural member you put in there that's not axially symmetric, you need to be able to align that to something. Otherwise, that structural member is going to spin on you. And you need to be able to get that nailed down. So the nice thing about this approach here, when you're putting in non-axially symmetric structural members, is that you have the capacity to have an element that's in that sketch that drives the pass segment line. You have an element in there that you could use to align it, instead of having to rely on geometry that's on the outside of that sketch. So that's very convenient having that. And we have sketch text in here, which defines the value of the structural member we're going to put in place. So again, we're going to be putting all this stuff in regard to a sketch, all these sketch elements together. We're going to get that fully defined in our model before we even put in a structural member that goes in place. So you want to make sure that when you're putting your structural member in here that it's going to be of the proper size. When you're in SolidWorks, sometimes you get lost in your model. If you go into the graphics area and it's first time visiting that, you really don't know what the size of some of the elements you're looking at. But this gives you a very quick visual reference in here because it's going to be pink in the background that you have you're supposed to have a 3-inch structural member in here. So if you put in a structural member in here that exceeds this on one side or the other, if it's too small or too big, you can tell right away that you don't have it correct. And number two, another advantage of having that text number in there is you have the capacity to look at your model real quick and say, okay, that's a 3-inch, that's a 2-inch, that's a 1.5 inch, and it gives you a pretty good idea what you're looking at just right off the bat. Again, avoiding the feature manager over here. So when we put this together, we start with a 3-point corner rectangle, not a center rectangle or a corner rectangle. You want a 3-point corner rectangle. We want to sketch this out at an angle. So the desire here with the sketch blocks, kind of a cardinal rule with sketch blocks, you want to make sure you don't have any horizontal or vertical relationships in here, because if you need to have your sketch block in a different orientation than what the horizontal and vertical are going to dictate. You want to make sure that when you exploit that sketch block, it's not going to rotate on you and kind of goof up your model. So if you get rid of those altogether, all we're relying upon here is perpendicular and parallel relationships in here. It works out really well. So we have 3 inches on the front. We have 1 inch, which defines where that alignment points are going to go and where the hole location is going to go ultimately. It's going to go right on top of that point. Now, if we need to, like in connection blocks, we have a second point back here, which is going to be 1.5 inches. So these are kind of arbitrary dimensions, is what I measured out in the field. But, if all of a sudden, something comes along, you need to change that, and all of a sudden it needs to be 1 1/4 instead of 1 inch or 1.5. Imagine this. You can go, and since I have hundreds of these sketch blocks throughout my model, throughout the 4 different legs and the top of the, of the tower, if I just change one sketch block, it all changes and all updates. what could quite literally take an hour or more in a regular model now can take a matter of seconds. So, to the worker, you can, take off early for the weekend if you want to do that. Tell your boss it's going to take 4 hours to update the model. Or if you're a really productive worker, now you can do a whole lot more work by just taking that in consideration and thinking about these things before you put your model together. Of course, we're the second group there. We're not the first group. We're the second group. We want to be productive. So that's what that sketch block is. And of course, if I update that sketch block, it puts it back where it is. And if I do go to the rebuild, it takes us right back to the sketch. But these are the super sketch blocks in here. And what I would do with a super sketch block, when I insert that block, and I have my SolidWorks block toolbar out, floating, because it doesn't really get in the way. But if I go and insert a block, I have my blocks all named over here. And SolidWorks doesn't give you the capacity to rename a block when you actually create the block. But you can go back into the feature manager tree and rename it there. And every block after that should have that name. So if I take my 3-inch long block and I put that in place in here and try not to pick up other relationships in here, I'm going to take that block and I'm going to explode it. So now you can see what we're doing. Now we have a nice old package together when we put in our structural member pass segments. We have our 2 blocks in the end and a short segment of our pass segment line. And all we do is define the bottom of the block down here. Get that fully defined, usually by 2 dimensions to do that. Some sort of sketch relation in here for that pass segment line with the 3D sketch line that we have in the background. Or if it's like one of those diagonals, all you have to do is plant these points in there and you have that in place. Then you have this defined in the very top. So once you get these 3 elements defined on the bottom, or 2 elements on the bottom, the third element we're going to define is this one. And just typically 1 dimension after that, like between this point, maybe some other structure that might already be existing in our model, that'll get that fully defined. All we have to do is put our structural member right on top of that, align it to either this line over here or that line over here in our sketch block, and bam, we got that structural member in place, and we don't have to do anything else with that once we get that in place. So let's go ahead and rebuild that, and we'll go back to our model in just a moment. Okay, so I'm trying to keep this short, and let's go ahead and take that block, and we'll delete that, and then we're going to go ahead and resuppress that. I deleted it. Didn't want to do that. I just wanted to delete that 1 block. We might have to go back in that sketch to do that. Boy, Control-Z is a really good friend of mine when it comes to SolidWorks. So I'm going to go ahead and delete that and just go ahead and rebuild the model. There we go. So I'm going to take this and I'm just going to go ahead and suppress that. So again, that's right at the top of the tree. Gets those blocks in there, kind of gets them out of the way. You can do all your definition of the blocks right away and then set up your model after that. So let's go ahead and take a look at our model so far. So I have a 3D sketch line, and what it is, I roll that back to the point where we have our main tower leg. The main tower leg is the only element in this whole design. It's got a direct relationship with the 3D path, or 3D sketch in the background, a 3D design sketch. Everything else is going to be stacked. So when I put in our support leg over here, which is going to be the next element in here, this is actually going to be coplanar with that surface. And when you make it coplanar with that surface in here, it's just a little bit set off from that 3D sketch, design sketch line. If you take a look at this and kind of scoot in on that because of the angles involved, this is our 3D sketch line, which is kind of in front of that, and this is our pass segment line, which is a little bit behind that. So you have to think about that. You want to make sure that every other element after this is going to be, it's going to have a reference to existing geometry. So the existing geometry over here is going to be our main tower leg. So this kind of goes along with the concept of stacking your elements together. These two have to come first before we put in our horizontals and diagonals. So if I take this 3D sketch line in here, or take that pass segment line sketch element in here and take a look at that, we have a 1/4 inch offset from that block, defining that first. We have a 2 coincident relationships in that block on that 3D, on that pass segment line, which you already defined in that super block I told you. And then we have a collinear, here it is. Here's a collinear relationship or coincident relationship in here. And even though it's a coincident relationship, between that line, our pass segment line, and that 3D design sketch line in the background, it really is on top of this plane, but on top of that line, that 3D sketch line, at its closest proximity. It isn't collinear with it, it's just close to it. But it fully defines it that way. And at the very top, Once we get that in place, we have an arbitrary 2-inch dimension between that and that, that 3D design sketch line that's on the top. And that defines it. So if you go to the rebuild button, that puts that structural member in place. So one last thing I want to show you is how you put in the horizontals in here. We're going to go ahead and drop that in place. I'm just going to do one in here, trying to keep this brief. And the first thing you do is you want to pick on a coplanar surface. This surface is coplanar with that one. And we're going to go up here to sketch. And don't have to do anything with the sketch toolbar up here. But if you go over here to insert a block, this is going to be our 1.5 inch. And we're going to go ahead and drop that in place. So it's kind of in an angle as you would anticipate. And we're just going to drop that there and then escape. One thing I like to do is I'm going to go ahead and fix one of these points just temporarily, kind of swing that into shape over here. And if we just take that block over here and explode it, now we get those, you get that barbell back. You get that pass segment line. You have the two sketch blocks that are connected to the either end of that. So we're going to take this line over here, and we're going to take that line, instead of making it collinear or coincident, we're going to make it parallel. And now we're going to put a dimension on it. So we can take that line and put it on top of that or below that, whether we want it to have to be on top of the 3D sketch line over here or below that. We're just going to put a dimension in here of like maybe 1 inch would be enough to set that off and kind of put that in place. So we're going to go ahead and take this point over here and that edge of where that fillet goes, just kind of an arbitrary dimension, make that 1/4 inch. I mean, this dimension here is actually measurable. This one is not, but it kind of gets it close. Then we're going to take this point down here, rotate our model just a little bit and pick up that fillet edge over here, make that 1/4 inch too. And once that's in place, it's all lined up, ready to go. We're going to go ahead and rebuild this. Kind of put that in the background. We have our sketch here in the background, sketch 1343. We're going to right click on that. We're going to change its color. We're going to make this probably pink like the other ones are. Pink stands out in the gray background. And pink used to be a common color in SolidWorks too, way back in the old days. And kind of miss that color. So kind of like to make mine pink. Of course, pink stands out too. In a gray background, pink really stands out, kind of like a cat and hat color. But anyways, that's all ready to go. If you were to go up here to Weldments, go to our structural member. I chose ANSI the inch. I downloaded that folder over here from the design library. SolidWorks doesn't start you with much, but it gives you a vast library that you can download. We're going to pick our size, which is going to be 1.5 inch by 1.5 inch by 1/4 inch, which is going to be that guy. And then we're just going to go out here and pick on that line. So that pink line is a little bit separated from the other line, that 3D sketch line in the background. Rotate your model. This is where we need to think about our alignment. So it's not really quite where we want it to be. It's on top of that sketch block instead of within it. So we're going to go down here to alignment. You want to make sure you do this every time. You go to alignment. We're going to click on this line over here, which is designed to do that. And now it's kind of sticking through the model and going in the opposite direction, but we're going to go ahead and flip that. So we can align the vertical axis or horizontal axis, or put in a different value for, for a degree, for the angles in here. And with that in place, it looks like it's sticking out in the right direction. So the way they put these towers together with a hole wizard or with a hole in place is that typically there's the roof of that structural member which covers that hole, rather than creating a trough or a gutter, which, if the roof or, if that L angle were sticking out in the bottom, he chose to do it this way, which sounds like a very worthy thing to do. And one thing about these towers, even though these towers have been in for decades and decades, with the galvanized steel that they use in this tower, and maybe simply because it's carrying electricity through it, I never see any rust in these towers. It's just incredible. These towers could last like the pyramids, maybe long after our civilization is gone, but there we have it in place. And of course, I would do these 1.5 inch pass segment lines going up the tower too. I'd do that in all in one feature. But for a demonstration, I just put those here. If I go to the green check mark, now we have that in place. So I'm going to take that, I'm going to go ahead and suppress that. And with that thought in mind, let's go ahead and suppress our line in here too, so we don't see that. Yep, and that one too. That actually drives the design. So let's go ahead and take our rollback bar and kind of roll that to the very end. So if you think about that, we have our 1.5 inch horizontals in here. We're going to put in our, we're going to put in not only our 1/2 inch horizontals in here. Let's go ahead and get the perspective right in here. Here's the front. So what we did is we put in that horizontal in here, right back here. Of course, there's a lot more stuff in here. But once we put that in place and put in our 2 inch diagonals, and we can go ahead and as we continue our model, we would put in our hole wizard hole locations after we put in those 2-inch diagonals. And that pretty much ended the presentation, but there's a lot more to this. Like, how do you get these connection plates put in? And some other elements in here too in order to make for a complete model. We need to get a chance to cover that in the session. But if you desire more information on that, I can get, I'm willing to share that with you too. But essentially with these connection plates are nothing more than surface models or thin extrudes consisting of a line back here, a line over here connected by a fillet. Then this line, which will define the back of the connection plate, is perpendicular to a plane that runs right down the middle of our model. This way, when we mirror our connection plates at the other side of the model, that they will be coplanar with each other. So when we put in additional structural members on the connection plates, they will be inserted on coplanar surfaces, which will remain coplanar as the model modifications are implemented. So that's a session in what probably took about 20 minutes, half an hour to put that together, but that's the session in a nutshell. If you got any questions, let me know.